Hello, my name is Jessica, and today I'm going to give you a little bit of background information about our intermediate collaboration task for this year. So, in summary, this is just going to be a little bit of background information on different types of extreme weather and how to survive it. So, what is extreme weather anyway? Extreme weather is any weather that is unexpected, unusual, severe, or unseasonable. And there are many examples of extreme weather, and some of which include natural disasters, which I'm going to describe in a little bit more detail. One type of natural disaster is avalanches or landslides, and these are caused by land or snow that is sitting on top of earth, weakening and sliding downwards. So these can be extremely harmful to individuals that live at the bottom of large mountains because they can be hit by large amounts of falling snow or rock. Another type of natural disaster is flooding. So, flooding is caused by heavy rainfall and insufficient soil drainage. And this causes water to build up on the land, and it can eventually rise above houses and cause severe property damage. And flooding is generally most common in low lying areas that are near bodies of water. Another type of natural disaster is lightning. So, lightning is an electric reaction between the atmosphere and the ground. You can think of it as a really big shock where there's lots of electricity traveling from the sky down to the ground. And lightning is often followed by thunder, which is a sound made by the shock wave, the massive shock wave in the air caused by lightning. Another type of natural disaster is hail or ice storms. So, hail is precipitation consisting of balls of irregularly shaped ice chunks, and hail forms during storms. And the storms cause the cloud condensation particles to rise and freeze. So, when they eventually fall down to the earth, they fall down as hail. Another type of natural disaster is tornadoes. So, tornadoes are a rotating column of air, and they're caused during storms when rainfall moving downwards is mixed with rising warm air. So, it creates this column of fast rotating air that basically destroys everything in its path. And similar to tornadoes in terms of fast rotating air, we have hurricanes. So hurricanes don't quite spin as fast as tornadoes, but they're often much larger than tornadoes. Unlike tornadoes, hurricanes form in the ocean, and they're characterized by a low pressure center, which you can see right here, surrounded by moving water. And when hurricanes make landfall, they cause high winds and a lot of destruction of property. Another type of natural disaster is wildfires. And wildfires are unplanned, uncontrolled, and unpredictable fires in areas of combustible vegetation. The last type of natural disaster that is common to Canada is earthquakes. And earthquakes are a shaking of the earth caused when seismic waves underneath the Earth's surface cause the Earth's tectonic plates to brush against each other, which results in a lot of shaking and a lot of structural damage. So you may have noticed that a common theme I'm mentioning is structural damage. So now I'd like to talk a little bit about preventative architecture. What preventative architecture means is there's ways that you can design your home if you know that you live in an area prone to a specific natural disaster to withstand that disaster a little bit better and minimize the damage caused by that natural disaster. So I'll be going over three examples that are not common to Canada. So the first example is tsunamis. So tsunamis are giant tidal waves that when they make landfall, they cause severe damage to buildings. They can flood entire communities. These tsunamis are usually caused by a massive movement under the Earth's surface that can be caused by either an earthquake or a volcano underwater, which results in this massive wave moving towards land. So they're very common in areas that lie along tectonic plate boundaries, such as Japan. So now I'd like to go through some key features of some tsunami-proof homes. So these 4 photos here are all examples of tsunami-proof homes. So one thing you'll notice about these homes that's different from regular houses is this house right here in the bottom left, you can see that it appears to be on stilts. And the reason for that is if a large tsunami wave comes in and makes landfall, that wave is more likely than not going to just flow underneath the house into this sort of area of open space. So that way, the top part of the house where people are actually living isn't damaged and the water is just sort of flowing through the house as opposed to right into the house. Another thing that you'll notice about this house up here is that this house is made of concrete as opposed to materials that your house or my house might be made of, like wood or brick. What you'll notice in this house in the top left corner is something called redundancy. So you'll see right here, there's this barrier. And then as you move upwards, there's a second barrier that's a little higher. And then as you move further inwards, there's this third barrier. And we call that redundancy in design. And that is so that if the first barrier gets damaged, there's additional barriers that keep the house safe. In addition to that, if for whatever reason the tsunami gets through all 3 barriers and the house is damaged, there's some redundancy in the design of the home. So there might be a couple of spare rooms so that if one room gets damaged, perhaps there's another room that isn't damaged that the family can continue to live in on a temporary basis. Another thing that you'll notice in the design, especially of this one over here on the right, is that the design has a steel frame. And using materials like steel to build the home, as opposed to something like wood, is that it increases the waterproof capacity of the home. What you'll also notice is that these homes are a little bit elevated. I did mention before the open concept sort of first stories with the strong foundation to keep the homes attached to the ground, but somewhat elevated. There are also there is also generally a narrow base and corners that kind of stick out of the home in the case of a tsunami, just to provide a little bit of redundancy in design. So the next type of natural disaster preventative architecture I would like to talk about is monsoons. So monsoons refer to a seasonal rotation of dry periods that are followed by extremely heavy rains. And these are common in what's called the intertropical convergence zone. So this is a special section of the Earth's surface. It's generally found in North Africa and the Middle East, where the Earth's atmosphere is in a region where high and low pressure meet to cause this particular weather pattern. So here are some homes in areas that are prone to monsoons. So what you'll notice is these homes are very open concept. Like there's just these like giant holes in the wall, giant holes in the floor. If you or I were living in a home like this, it would be considered a hazard. You would just like fall in a hole. But here they're designed this way actually on purpose. So a common problem in these homes is that the airflow in these homes is not great because of these long dry periods. So you want to have as many large windows or large holes in the home as you possibly can to let that air into your home so that the house is well ventilated. What you'll also notice is what appears to be a giant pool in the middle of the home. And this is not actually a pool. This is actually water coming from outside during the periods of heavy rain. So these houses are designed to have essentially a hole in them where water can build up during the periods of the monsoon where there are heavy rains, and that's to prevent flooding. Another thing you'll notice is the roof. So you can see here that the roof is very reflective, and there's a lot of what you would call airspace in the roof of this home, and that is also to better ventilate the house. Generally, these houses are also made of fairly lightweight materials, so fairly lightweight wood, and that is because these materials have lower thermal properties. So it doesn't keep the warm, dry air in the house when it cools off at night. So it really minimizes the amount of time that there's warm, dry air in the house. So the final natural disaster with preventative architecture that I would like to talk about is volcanoes. So volcanoes are a rupture in the Earth's crust, which allows some of the material of Earth's core, magma if it's inside the Earth and lava if it's outside the Earth, to escape. And these volcanoes often form on the boundaries of tectonic plates, where the two tectonic plates are pushing against each other. So they're converging towards each other to form this little mountain with a hole in it, exposing the Earth's inner core. So here are some volcano-proof homes. So the first thing you're going to notice in these homes is the roof. So for example, here in the bottom left, this is a really steep roof. Same sort of thing in the bottom right and in the top in the middle. It's a very steep roof. It's a steeper roof than any roof you would see probably in your neighborhood. And the reason for this is if a volcano explodes and debris hits the roof, it's such a steep roof, it's just going to bounce right off and slide right down. On the topic of sliding right down, you'll notice that these roofs are very smooth and they're often made of steel. So they're not made of shingles. And that's for the same reason. If the volcano explodes, the debris is going to hit the side of the roof and then just slide right off the roof. It's not going to get stuck and weigh down the house and cause the roof to cave in or anything like that. What you'll also notice here is there's some carports here. Here is kind of their open concept entryway. What you'll notice is this roof is very thick. These pillars are very thick, and that's to protect anything that is out and in the open. In the case of a volcanic eruption, you don't want a fairly flimsy roof over your carport. You want things to be well protected. What you'll also notice is a lot of these structures are very short and wide. And that is also on purpose because sometimes the earth might move a bit when the volcano is erupting. And if you have a really tall building, it's more likely to sway back and forth than a really short and wide building. Finally, what you will notice about these buildings is they all have very simple shapes. So if you can remember back to the buildings that were designed to be tsunami proof, they had the narrow little bases and then stuff like sticking out on the sides. It actually looked pretty cool in my opinion architecturally, whereas these sort of look more like your typical house, the classic triangular roof and flat base. This is actually on purpose. You want your house in the area of a volcano to have a fairly simple design, no sharp corners, fancy bends or anything like that. So you don't have anything jutting out waiting to be hit by debris. It's sort of like if there's things around you being thrown. Let's say you're at a party and there's like a confetti machine and you want to get as minimal confetti on you as possible. Do you think it'll probably be better if you curl up in a little ball so you only get it on your extremities instead of like doing the starfish where you'll get it everywhere? It's sort of like that with these houses. So the last thing I would like to talk about before we finish off this presentation is something called motifs. So motifs are a theme that you can find in literature. You can also find it in artwork, which is what I'm going to talk about today. So a motif is a distinct feature or dominant idea in a piece of art. So here's an example of artwork with motifs. So as you can see here, the common reoccurring motif is this flower theme on the inside surrounded by this diamond theme on the outside. You can see it here in the central piece as well as in the peripheral pieces on the outside. They may have slightly different shapes, however, the overall theme is still there. Another motif is the color scheme. You can see that there's several colors that are common to the piece, including blues, greens, reds, and oranges.